We're told that the Sun is a massive ball of burning gas 93 million miles away. But if that were true, then all the light that arrives here would be parallel because it's so far away. And it has to be parallel because one of the most often cited supposed globe proofs is Eratosthenes' experiment that was presumed to have been conducted 2,000 years ago between Alexandria and Syene, by which he calculated the size of the Earth. For that calculation to be accurate, the light must come down parallel. So the Sun has to be massive yet very, very far away. The only problem is that that's not what we see. If you go out on a sunny day with broken cloud, what you'll see is that light comes down at angles, diverging angles. And that means that we can follow those light rays back to the source and triangulate the Sun's height above the Earth, proving that the Sun isn't millions of miles away. Now the globe believers will tell us that what we're actually seeing is due to perspective. But that would only be the case if the light rays were coming directly towards us. Only then would they appear to diverge from the source due to perspective. But in this case, the light is coming from above, striking the surface in front of us. So we're not getting that perspective view. We can also show images of where a plane casts a distorted shadow on thin cloud below it, proving that the light rays themselves are definitely diverging. But we can also perform physical experiments that prove that these crepuscular rays, as they're called, can only be recreated with a light source that is small and close. The other problem with their conception of a massive Sun 93 million miles away is that during a solar eclipse, the Moon, which is 2,000 miles wide, casts a shadow 70 miles wide, which is impossible, as you cannot have an object casting a shadow smaller than itself. The way the globe believers get around it is to show us diagrams of the Sun's light reaching the Earth at converging angles, projecting a dark 70-mile wide umbra and a much, much larger penumbra, much larger than the Moon itself. Of course, that's not what we see during a solar eclipse. We don't see a long period where the Sun dims as a several thousand-mile wide penumbra sweeps over, followed by a period of darkness in the umbra, and then a further long drawn-out dimmed period, after which the Sun returns back to its normal brightness. No, what we experience is a definite and well-defined shadow as something passes in front of the Sun. The Sun is definitely small and close.
Ahora es el momento. Qué buena, weón, mira.
Now, I totally understand why it seems that you should be able to see a big, bright, shining light hovering above a flat Earth from anywhere on that Earth. But in the flat Earth model, the known Earth is approximately 20,000 miles across. The Sun is about 34 miles across and about 3,100 miles high. So to put that in perspective, imagine a table 2 meters wide in a completely dark room, and you're holding a small but very bright light bulb, 3.4 millimeters across, and you are holding it about 31 centimeters above the table. What you'd see is a circular pool of light directly on the table, beneath the light bulb. But on the other side of the table, it would be in darkness. Now, it seems to our mind that if you were on the other side of the table, you would see the light because it's, above the table. But that's not true, because on that part of the table, it's in darkness, meaning that the light isn't physically reaching that part of the tabletop. Now, paint a flat Earth map to scale on the tabletop so that Europe is directly underneath the light bulb and Australia would be in darkness. And even though you could argue that you could put your eye right next to the edge of the tabletop and still see the light, well, let's say the pupil of your eye is about 1 centimetre above the tabletop. At that scale, your viewpoint is 100 miles above the flat Earth, and yes, in that case you would still see the light. This model actually matches observation. In 2014, an amateur rocketry team in New Mexico launched the Go Fast rocket 73.1 miles into the air. But when a flat Earth researcher called Refi studied the footage, he noticed that the moon was visible. But when he checked on timeanddate.com, he found that the moon was actually above Australia at that time. So it would have been impossible to see it if it was on the other side of a globe, but absolutely visible across the other side of a plane from 73 miles up. We're also told that the sun sets because as the Earth rotates us away from the sun, it's actually obscured by the physical curvature of the Earth. And yeah, it does kind of look like that's what's happening, but there is actually another explanation for this. Imagine you are in a long dark corridor that's let's say half a mile long, and the only light is a light bulb that's directly above your head. That would correspond to midday wherever you happen to be. Now if you walk backwards from that light bulb, it would appear to sink down in your field of view. That's perspective. The further away you get from it, the lower it will appear. It doesn't physically change its height, it just appears that way to your eyes, until eventually it will disappear behind the horizon formed by your eye's vanishing point. Your eye has an angular resolution of 0.2 degrees. So if you're standing fairly near to the light bulb, then the angle formed between the light bulb, your eye and the spot on the floor directly beneath the light bulb is a fairly large angle, say 90 degrees. But as you move away from it, that angle gets smaller and smaller and smaller until the angle reaches 0.2 of a degree. And anything at that height will disappear beyond the limit of your sight. The proof that this is what's happening is many times we can see time-lapse footage of the sun that shows it getting smaller as it moves away from us. Now, that's not always the case, since the sun is travelling around the North Pole. The closer you are to the north, the less you'll see the size change. But from locations beyond the equator, you'll absolutely see the sun's size change. And that could never ever happen if the sun was 93 million miles away. You wouldn't see the sun change at all. There's also an effect that occurs under certain conditions called atmospheric lensing, where the sheer amount of atmosphere, as well as the rain between you and the sun, acts like a lens and a prism, magnifying it greatly and tinting it red, which leads to another observational proof that the sun setting is an optical effect. At such times, when the sun is setting over the sea, and it seems as though it's half hidden by the horizon, then you can zoom in with a high-powered zoom camera and see that it's actually still above the horizon. It's just an optical illusion. Finally, we're told that the 23.4 degree tilt of the Earth is the cause of the seasons we experience, as if the slight difference in the orientation towards a sun 93 million miles away could possibly cause temperatures to vary from 38 degrees centigrade all the way down to minus 27. In the flat Earth model, the sun doesn't just circle the Earth above the equator. It does a sort of spiralling motion from the Tropic of Cancer out to the Tropic of Capricorn. So when the sun is circling over the Tropic of Cancer, the one closest to the north, then it's summer in the northern hemiplane. You see what I did there? Because the small close sun is physically closer to the northern locations and further away from the southerly ones. In fact, if you get close enough to the North Pole, you see the sun circling around you without setting at all. And if you set up a camera to follow the sun, and then it would actually have to do a 360 degree arc to keep it in shot. However, if we lived on a rotating sphere, then the camera would basically have to move side to side. As we follow my head, you can see the sun would actually just go side to side. 6 months later, it would have spiraled out to the Tropic of Capricorn, and it would be, you know, winter in the north and summer in the south. There are also a couple of deceptively simple questions that I like to pose to physicists or astrophysicists that have not yet been answered. So, here's the first. Why were the Apollo astronauts weightless on the way to the moon?
Roger, copy, and we see the disk keep flashing with a 651. In fact, we can read registers 1 and 2 quite clearly. Yeah, the high gain angle telling us which way the Earth is. Copy. That's a beautiful picture. Clarity is outstanding. We can also give you the time of day in our system of mission elapsed time, 34 hours, 16 minutes, and 15 seconds. Roger. Can you see that clearly enough, Charlie? Roger, Apollo 11. We can see it counting up every second. We got 34:17:02 now. It's getting a lot better now, 11. Mike, you coming in 5. I got a good... Well, I put on a code and time if I'd known about this ahead of time. Is Buzz holding your cue cards for you, over? Cue cards have a no. We have no intention of competing with the professionals, believe me. We are very comfortable up here, though. We do have a happy home. There's plenty of room for the three of us, and I think we're all learning to find our favorite little corner to sit in. The zero G is very comfortable, but after a while you get to the point where you sort of get tired of rattling around and banging off the ceiling and the floor and the side, so you tend to find a little corner somewhere and put your knees up or something like that to wedge yourself in, and that seems more at home.
Now, that might seem like there's an obvious answer. You know, they're in space, so they're weightless, you know, duh. But that's not it. To get the answer, we need to understand the question. And to get there, we need to actually understand what an orbit is. Sir Isaac Newton came up with a thought experiment. Imagine a cannon on top of a high mountain. When that cannon is fired, the cannonball takes a curving trajectory towards the ground. Now, if that cannonball is fired at a higher speed, that curve becomes longer and shallower, and the cannonball falls to the earth further away. Newton reasoned that if the cannonball was fired fast enough, its curved trajectory towards the ground would be so shallow that the Earth's surface would curve away from it. So, before the cannonball could hit the ground, the Earth would have curved away, and the cannonball would continue to fall around the Earth continuously, continuously missing the ground. Gravity is not absent. In fact, the cannonball is falling towards the Earth under its influence, but it keeps missing the ground. So that's what supposedly the International Space Station is doing 250 miles up. It's moving fast enough so it's falling around the Earth. And the astronauts inside it are also falling. And because they're inside the ISS, it gives the illusion of weightlessness. They're all falling together. Of course, this experiment would have to take place in a frictionless environment, because if the friction were to slow down the cannonball, then its trajectory will become less shallow, and then it will be accelerated towards the ground. But here's another dependency that Newton left out. For this to work, the cannon must be fired at a tangent to the Earth's surface. So the direction of gravity, which is towards the centre of the Earth, is 90 degrees to the direction that the cannonball is moving in. So gravity does not affect the cannonball's speed or direction. So if you were to aim the cannon just even a fraction of a degree down, now gravity is altering the speed and direction, accelerating it towards the ground. If you aim the cannon even a fraction of a degree up, now gravity is acting as a drag, which means the cannonball will slow down, reach an apex, and then accelerate towards the ground, and it will hit the ground. So orbit and the illusion of weightlessness only works when the direction of gravity is 90 degrees or less from the motion of the cannonball. Any more than 90 degrees, then the cannonball is climbing away from the Earth, and unless it can find some way to accelerate, it will eventually reach an apex and fall towards the Earth. Now, consider the Apollo rocket. As it blasts off, the astronaut experiences twice the force of gravity. That is the normal gravitational pull plus the acceleration of the rocket. As the rocket achieves orbit, now they are falling towards the Earth but missing it, so they will appear weightless. But as soon as they leave orbit towards the Moon, now they are climbing away from the Earth. So the astronauts should once again experience twice the force of gravity, pinning them back in their seats and not allowing them to float around supposedly weightless. And since the Moon's gravity is only 16% of Earth's, halfway between the two, they're still climbing away from the Earth and not falling towards the Moon. The second question again has to do with gravity, and it is, how does gravity work if mass is not a factor? In both conceptions of gravity, mass is the key defining factor. In Newton's conception, well, two masses attract each other. In Einstein's conception of gravity, a mass will warp space around it, and anything going near it will literally fall towards the mass. But let's do a thought experiment. Imagine you have an empty gas bottle, and that gas bottle weighs a pound. Okay, so if you put that gas bottle on a scale and zero out the weight of the gas bottle, then fill it with 10 pounds of helium. Well, you can compare that full gas bottle with an 11-pound weight, and they will act exactly the same. So, they'll both fall to the ground when you let go of them. You put them on scales and they'll both weigh, 11 pounds. So now, if you evacuate that helium into a balloon and compare it to a 10-pound weight, you know, just consider this, you know, the same amount of helium atoms, 10 pounds of weight, yeah, are now in this balloon, and you're now comparing it to a 10-pound iron weight. Same mass. Mass hasn't changed. Now, if you let go of them, the helium balloon's going to go up, the iron weight is going to go down. It has nothing to do with mass. It's relative density. And this thought experiment proves it.